right, so let's just get started. Welcome everyone to this virtual showcase on reproducible research in data science. So this is a quite unique event, so I want to give you a bit of a background. So earlier this year, MIDAS organized a reproducibility challenge with the goal of promoting the good work of our colleagues at U of M and to showcase best practices and tools that our entire community can adopt. We received many wonderful submissions from across the campus. These presentations from May to August will offer many different perspectives, including providing a definition of reproducibility and what can and should be reproduced, making comprehensive documentation that allows for others to reproduce the results in a particular project, developing general platforms for coding or running analyses that standardize the methods for reproducible results across studies, metadata tools and processes to improve the robustness of results in the presence of variations in data, in the computational environment and human decisions, methods to test the consistency of results from multiple projects, and improving reproducibility with limitations on data sharing, such as with patient data. So the judging panel of the Reproducibility Challenge have picked a number of teams to put together this virtual showcase. It doesn't mean, I want to say, it doesn't mean that the projects not chosen are less good, but the projects featured in the showcase are particularly suitable for this format. So I also want to mention that the videos and slides of the showcase will be online later on, and we'll also be building a resource collection online for interested people to check out what tools they can adopt. In addition, we will host a Reproducibility Day on September 14th. We'll announce winners of the Reproducibility Challenge who will receive cash awards. There will also be tutorials, panel discussions, and workshops on the day. So today we have two speakers to share the hour. I'm going to introduce Jie Song now, and then after she finishes, I will introduce Oliver. Jie Song is a graduate student in the Department of Computer Science and Engineering. The title of her presentation today is C2 Metadata, Continuous Capture of Metadata for Statistical Data. This is a tool to automatically record metadata, especially variables, when the data undergoes transformation with common statistical packages. The judges of the Reproducibility Challenge like this entry because it allows the documentation to travel with the data as it goes through format transformations and allows others to reproduce the analysis with variations in the computational environment. Before I hand this over to Jie, I also want to mention that audience members should feel free to write down your questions in either the Q&A or in chats. We will probably allow a few questions after Jie finishes, but after both presentations are finished, we'll have a longer Q&A session. All right, so Jie, you can take away.
Okay, thank you for doing the introduction. So welcome to our presentation. My name is Jie Song. I'm a PhD student with CSD department. This is a work that we work together with ICPSR, the Social Science Data Hub at the University of Michigan. So I'm the presenter, and George Alter, who is the lead of the project, he's also in the meeting. So the name of the project is called C2Metadata, Continuous Capture of Metadata for Statistical Data. So let's get started. So here is a simple illustration of how data is created and consumed from its birth of the data to the consumption of the data in the simplest way. So first we have data creation manually or from computers. And with the data available, people are encouraged to share it in data archives, in data lakes. And then the consumers, they go to this website, they search for the data that they find proper for their use cases, and they will actually do some analysis, computations with this data. So nowadays, the data is encouraged to share not only itself, but together with the metadata, the data that describes the data. with this metadata information, the consumers will get a better understanding of how the data is collected, created, and how it's shared, what it's about, more details of the data. So they will find whether the data is really what they are looking for based on the metadata information. So as we say, as data can be created manually or with computers, with metadata, there are also some tools to help with the generation of it using machines or by hand. But one thing to note is that there's no universal standard for metadata. Different communities, they have their own standards for metadata. So like social science, they use DDI XML format for their metadata. Ecological data, they use the EML format. There are also some biological data standards called Darwin Core, and many general purpose metadata standards, such as Dublin Core, MOS, and Google Dataset Search, they also launched their standards called schema.org. So with this various metadata standards, we will look into what happens in the metadata that's not emphasized in current date. So this is an example of a data page for this data set called world population from year 1950 to 1975. And on the left-hand side, we have metadata information about it. For example, from the name of the study to the version date, the project investigators, and more details we know, the summary of the project, the citations, and some other details not shown here, such as the variable information, data-related publications, and even if you can export it in a chosen format, such as DDI or XML. And on the right-hand side, we show the DDI format for its metadata. So you can see it's machine readable rather than human readable. And the DDI standard actually choose the tags to include for the metadata. Some of them are mandatory, some of them are optional. You can have one or multiple of these tags based on their standards. So we'll have an example here of how the research data are created and consumed in the old way. So for example, the research data, one of the most popular ones creation way is through surveys, especially in social science. So the surveys, they can be conducted using computer-aided interview software, also known as CAI. So this software, they can be telephone-based, personal-based, or web-based. So there's no paper questionnaires. People just fill it out through forms or web forms. And the thing to note is that the CAI program itself which is the questionnaire, that is the metadata. So after respondents fill up these questionnaires, the data are created together with the metadata in an automatic way, which is a good thing. So if user is about to publish the data, they don't have to create their own metadata. But then the consumers come, they found this data, and they want to adapt it to their own analysis or use cases. So they write command scripts and use statistical softwares to process the data to do some transformations. So here we list the 4 languages commonly used nowadays, which are SPSS, SAS, Stata, and R. So then the original data after processed with the command script are creates the revised data set. The thing is that the revised data set is no longer matching the original metadata, because this transformation, the changing, the variable information may all change with the transformation. So if they want to share the revised data again with the revised metadata, there are some things to note. So first is that the question test is no longer there. The interview flow is no longer there. We don't know the variable provenance, and the transformation information is not documented in the new metadata. So if the user is about to share the revised data, they need to manually create a revised metadata. What if they get some help from the statistical softwares? Does the statistical software have any function to help creating the metadata? Well, they do, but in a limited way. So easily we can get the variable names, variable labels, value labels, this kind of basic metadata information from statistical softwares. But the provenance information, how the variables are changed, is not included in statistical packages. So if you are to manually create the updated metadata file, you need to include this information by yourself. So this inspired us to create our project to make a solution to the problem. So we want to say that if we are given the command script and the original metadata, is it possible that we have a tool that automatically captures the transformation in the metadata to create the revised metadata that match with the revised data? So here, there are many challenges in this process we have encountered, but here we just emphasize two of them. The first is that statistical packages, they are so disparate. They vary in different ways. So if you are to use any one of these languages as the description of the transformation process, it's not a good choice. And the second challenge is that, so if we are about to create something new to represent the transformation, we want to make sure that the command script used before and after the translation will create the same revised data set. And that functional equivalence is hard to get. So before we step down to how we solve the problem, let's choose which language we want to support. So here we have a graph for ICPSR downloads by format for the years period. And on the left-hand side, we have the number of all downloads. And the right-hand side, we have the studies with all formats. And it can be seen that the majority downloads are by delimited text. So for this format, we assume it can be processed by any of the statistical packages. But other than that, there are some major languages used. For example, SPSS, Stata, SAS, and R. So based on this kind of information, we design our development stages. So the first stage we have already completed is to create support for SPS and Stata. And second stage is wrapping up as we support for SAS. And now we are developing the support for R. So R is different from the previous languages because it's more like a general programming language. You can do many other things other than data transformations analysis with it. So to be able to support for widely used data transformations, we limit our support scope to DPL, LYR, and tidyverse packages. And the next step to do is to support support for Python. We, similar to R, decided to make it available for pandas package, also widely used for data transformations. Okay, so back to our challenges. We have talked that statistical packages, they are so disparate from each other. And they are disparate in three ways mainly. First is data model. Second is transformation and representation. And third is the scope of transformation supported. So left-hand side, we have an example of how they differ. So first, we have the original data and the original metadata. Just a snapshot of the data summary. And then we have two transformation scripts that does the same transformation. The first is SPS, the second is Stata. So we can see that they first compute a new variable based on some computation, and then they create a label for the variable. The third step is a filtering, and the fourth is a sort of the cases. So, so we are not able to see the data models now for these two languages. But for the transformation representation, the syntax is quite different. Well, users may be expert in one language, but not in another. And the third, we also talked about the scope of transformation supported that's quite different. Like the function supported in one language may not be available in another language. So based on this information, we decided that using one of the language nowadays available to the users is not a good option to make a complete representation of data transformations across languages. So we are proposing to create something new as an intermediate language specialized in data transformation representation. So there's a common syntax for whichever language actually used. So the source language, which is the actual statistical language used, can be translated into this new intermediate language, and the intermediate language will be perfectly integrated with the metadata standards. So we choose to use the JSON standard or the XML standard for ease of reuse of computer applications that's readable by the computers. So then inside the black box of C2Metadata, we have the two major components here. The first is a script parser that takes in command script in one of the statistical languages and convert it to this intermediate language, which we call a standard data transformation language, SDTL. And then SDTL, together with the original metadata, will be passed to the metadata updater and convert it to the revised metadata that matches with the revised data. The C2Metadata is a project that we work together with multiple collaborators, ICPSR, NAES, MTNA, NORC, NSD, Collectica, supported by NSF. So each company or collaborators work on different part of it, and we will talk more about it in details. So SDTL is the language we have designed for this purpose. I won't talk too much of the details of it. So the web link on the top of this slide is the user manual for the language. If you are interested, you can click on it and look over the language. So please be aware that because we are under development and we are updating the language and software from day to day, so they may change over days, and some functionalities may fail because of maintenance, but we are trying to work it over. So SDTL is, we borrowed the idea of type inheritance from computer science community. So the elements are all typed, and from the base type, they will inherit the properties, and the subtype will have more specialized functionalities. So for example, the base type is called type. It has the source information, whether it can change dates, produce date for data frames, properties. So these properties, some of them are mandatory, some of them are optional, and you can have one or multiple of them based on our standard. But basically, it describes what kind of original language is used for the script, and whether it makes any general changes to the data. So then the transform base and expression base, they inherit from the base type. So we have 6 different groups of types for the transform base. So there are types that actually add or modify the variable without any structure changes. And 2 of the most widely used ones are compute and recode. And then there are also other transformations that operates on metadata. They may add, delete, or update on metadata such as name, labels, data types, or display properties of a dataset. Also, other transformation operations that interact with the file system to allow it to do any loading or saving to the files. We also support structure changes. Here I list some examples, such as append dataset, drop cases, merge dataset, and reshaping to do some pivoting or reshaping of the dataset. We have other transformations for flow controls and the metadata information like documentations. And for the expression base, the most important one is function call expressions. So for function call expressions, we include a thing called function library that is extendable to include new functions. So some of the mostly used ones, including like string operations, method operations, logical operations, are also available in other languages. So this is a general structure of how SDTL is designed. And yeah, go to our link for SDTL if you are interested in this part. So then I will briefly introduce some of the major steps in C2Metadata. So first is the script parser that takes the command script as the input and create the SDTL script in JSON format as the output. This is developed by NSD and Eclectica, as they are in charge of different languages, as we have one parser per language. So for different languages, we create ANTLR rules to break the command into token streams. And then these token streams will be reorganized into abstract syntax tree. The tree worker will actually work over the AST and convert it into SDTL in a templated way. So then SDTL is outputted as a JSON script. So below is an example of how it works internally in the script parser. So given a Stata operation, we convert it to AST and then reorganize the SDTL. So this is not a real SDTL, it's just a simple representation for SDTL because the JSON is too long. So for the script parser, MTNA, who is in charge of developing the parser for SPSS and R, they have created a standard independent tool that's available online. So you are able to upload a script in SPSS or R, and then it will return you a corresponding SDTL script. So you can work with it with your own script. And the same thing is that we are updating the websites, so be careful if it breaks. Okay, then it comes to the second step, which we update the original metadata with the SDTL information. So given SDTL and the original metadata, the metadata updater will convert it to a revised metadata. So here we show a pipeline of how this part works. So first, we have a pseudocode generator that actually converts the SDTL JSON script to the pseudocode representation. It's like a natural language format that's human readable. So the JSON format or XML format is not like user-friendly. And if you don't know any of our language or any of the other statistical languages, you are able to understand what it does from the pseudocode representation. And then through the XML updater, the transformation information is embedded as part of the metadata. And this part, we do it for DDI and XML format. Both of them are XML based. And in addition to that, we have a new part called codebook formatter. It's an alternative way of representing metadata in a user-friendly way. So the metadata is now in an HTML-based format called codebook. So then we'll have a simple example of how it works. Suppose that we just want to recode a continuous variable into a categorical variable. And this is a solely operation for in a command script. And like this is a page landing page for the continuous variable, and what it and the categorical variable corresponding to it after transformation. So suppose we have the Stata script on the left-hand side. So it generates this new variable by recoding the old variable HH income. So then after the script parser, it will be converted to the JSON format on the right-hand side. So we only keep some of the simple properties here. It's for illustration purpose. So we can see it has the tag called command for the compute command, and then the created variable called target, and what kind of the expression to create this command and the recode command in much details. So after that, SDTL is converted to the Pseudocode representation on the left-hand side. So that like humans can actually read it. We have the derivation part from SDTL. So it explains this operation as set variable HH inc cat equal to variable HH income, and recode this variable such that these are the rules used for recoding. And then the next step is to update the old metadata with the derivation information as the revised new metadata. So for the DDI format, we have this part as under the derivation tag. And the other part is pretty similar to what we have seen in the SDTL part. So this is the website to the project that you can play with. So this is the landing page. You need to sign up and sign in first. And then it will redirect you to the submission page. So you can select the code script in this part. So here we upload a command script called compute recode in SPSS format. And then you need to specify what's the input data file name in the command script, and also the original metadata in DDI format here. And then you're good to go. Because it takes some time to do the conversion. So instead of letting the user wait on the website, we actually send a notification to your email account to let you know when the revised metadata is ready. So this is the email I've got from the website. So it says you can download your revised DDI metadata or HTML codebook using these two links. So I have these two links available in the slide. You can download it yourself. So this is the generated codebook in HTML format. So, you will get a study description. This is from the original metadata, and the citation also from the original metadata. So the part below are updated from our SDTL from our SDTL transformations. So it has the file description, variable description, and the temporal variable used during this transformation phase. So HTML allows you to interact with this tags. So after we do some collapse and click on one of the variables that's called HH size, you can actually see the value distribution. So this part is from the original metadata. And the derivation part is from the transformation we've got. So it describes how it's created in natural language, and then what's the original command used to create it. and also the SDTL representation for it. Because SDTL is mostly for computer use, so we hide that information from the user, but you can actually look into it if you click the button. So that's a brief introduction of the C2Metadata project. And there are 3 more things I want to talk about regarding the current process of the project. So it's a 3-year project, and we are launching, in addition to C2Metadata, we are launching SDTL version 1.0 in July. So the user guide is available here, and we are welcome to like comments during the comment period from July to August. So your comment will help us to make a better standard. And the second thing is that the DDI Alliance, the social science metadata standard, is actually bringing SDTL as a part of the standard, which is a pretty good thing because it will be maintained and active even after the end of the project, and make sure that there are more use of the standard. As DDI Alliance thought, it's filling a blank that, it's filling a current need that under their specifications. The third thing is that we have got a 1-year extension from NSF to develop like byproduct downstream applications for C2Metadata. So we are in cooperation with the Brown Dog project to develop the R Parser, as R and Python, they are the new tools to use for statistical analysis. And another project we are working with is called Prop1. They create graphic visualization for variable trackings during transformations. But before SDTL, they ask the user to give input on the variable informations. But with SDTL, they can actually automatically extract the transformation information from SDTL. So the user don't need to give any input to this process. So that's basically all of what I have. So I have talked about the C2Metadata and SDTL as 2 parts we have got. The C2Metadata automates the capture of data transformations in the metadata documentation, which is a part not emphasized enough previously. It eliminates this costly manual documentation process, which is good for the users. Also, it helps to improve the data transparency to help people get to understand what the data is about. Because it also improved the metadata quality for this transformations part. So I think it will help with dataset search as launched by Google. And for SDTL, we have developed a standard for like data transformation representations. And it can be easily extended for other languages other than the ones we are currently supporting. And because of this intermediate language representation, it can like interact with other communities and representations such as SQL queries. And we found it can also be used for language conversion. So like the figure below, if you want to convert between any 2 languages, there are this pairwise language conversion tools you need to create. But with SDTL available, even if you have a new language, you can just create a mapping between the new language and SDTL, and it can be converted to other language without much effort. So more things to consider is that I think it will be beneficial for research in data services such as data sharing, publication linkage construction, because like before this tool available, the publications, the data set in publications, they actually gone through different kind of languages for transformation processing. With SDTL, we can build a linkage graph using this like one single representation. It can also like help with provenance tracking during this process. Okay, any questions?
All right, thank you both, and Oliver. Let's see. I don't see any question from the audience for now. And given the interest of time, we really are at 3 o'clock. Let me just ask one question, to both of you. So, and that is, this kind of effort of building standards and trying to promote standardized practices and providing guidelines are really very critical. But in reality, for individual research teams, there are a lot of barriers for them to adopt such standards and guidelines. In addition to a lack of awareness, there are also issues about how much effort they need to put in. Whether it's easy for them to learn how to use this, and whether whether they can see the benefit. So my question to both of you is, well, actually, it's a couple of questions. One is, how do you help the team or handhold them, right? So they can actually make it make it as easy as possible for them to adopt your tools, right? And second is, how do you demonstrate the benefits to their research by using the guidelines and the standards? And ultimately, though, whose responsibility is it, right, to promote these guidelines, right? It shouldn't be individuals who actually develop these guidelines. It might be some, larger entities. So.
Okay, can you hear me now?
Yeah.
Okay. So for the first question, actually, I agree that we first borrow ideas, borrow existing ideas. And another a thing that we have is that we have people from different communities when we design the standard. It's like Jag and I, we're from the computer science community, and we are more aware of the users of SQL, of databases, and like database, they have standards based on like mathematical creations, like the algebra. And we also from communities from the social science and the biological communities and geological community. So those are the users of different kinds of data. So we know what kind of transformations we want to include, what's the scope. And then from different community, we brought the idea of the design of the language. Like we borrow idea from SDTL, from SQL algebra, and other people, they borrow idea from statistical languages. So you have to be the user yourself, like to start with the design. And then what we have is a lot like use cases. We have got scripts from different websites that we try to say, if this is an initial design of the standard, whether this simple commands can be like correctly represented and extend from there. So you start from the needs. And the second is that actually users, they don't have to learn DDI, the standard, or STML, because they are all like machine-based. They are hidden from the end users. What the end users provide is just the command script, which is what they already have, and the original metadata, which is already have together with the data. So you don't have to touch any of the hidden parts of our project. They just upload what they have for now, and they get the updated metadata. So I think that's the magic of making it automate. So only for like developers that want to touch the internal of SDTL or to introduce a new language for this like inside this transformation path, they need to interact with SDTL or the internal of the system. So for them, we have already provided a user guideline, which we will release on July the 1st. And also together with some examples. And as we have talked about, because DDI is introducing STL as part of the standard, so they will keep track of the development of SDTL as we have more and later versions. So they will have a platform where users can leave their comments and they can borrow ideas from the comments to improve the versions. Okay.
All right. We're already a few minutes past, so I'm not seeing any questions from the audience. So I would say let's just end here. Thank you very much for both of you for the wonderful presentation and the wonderful work.